Our design process began with a simple question. How can we grind grains efficiently in communities where electricity is unreliable or unavailable?
We looked at traditional methods like hand-grind grinders, flywheel systems, stationary grinders, and even bicycle-powered grain mills. From this research, one recurring idea emerged. Rotational energy is always at the center of grinding.
Since motorbikes are extremely common and easy to use in these communities, we asked ourselves, what if the motorbike itself could become the central power source?
This became the foundation of our entire project.
Our earliest concept was very ambitious. We imagined a grinder that could function while the motorbike was moving, so that a rider could grind grain as they traveled.
However, after exploring the engineering challenges, several problems became clear. Number one, weight distribution became unsafe when attaching the grinder directly to the bike. Number two, there were no structurally safe mounting points that were aligned with the bike's rear wheel. Number 3, the grinder shaft and the wheel could not be connected in a stable or precise manner. And number 4, the added mass made the bike harder to control.
These obstacles made the mobile grinding concept impractical, so we shifted our focus to a stationary grinding system powered by a stationary motorbike.
To explore the idea visually, we created a cardboard prototype showing the grinder, the flywheel, and the potential connection to the motorbike wheel. This gave us a quick physical sense of spacing, angles, and alignment.
The cardboard model helped us realize an important limitation. There was no direct way to line up the grinder shaft with the bike wheel. There simply wasn't enough room on or around the wheel to attach the grinding mechanism safely. This showed that we needed a completely different method of transferring rotational energy.
We created several sketches of the possible mechanisms. Two main approaches emerged. Idea 1, a standing grinder, that the motorbike and the stand are stationary and kept at one location. Then the motorbike would travel to it and in order to grind the grains. This idea was simple, safe, and structurally stable.
Idea 2, a portable grinder. The grinder attaches directly to a bicycle-like frame connected to the motorbike. This could allow grinding while traveling or moving around.
But after comparing the pros and cons, the standing grinder clearly made more sense. It was safer, easier to build, easier to repair, and it didn't require the perfect weight balancing.
This allowed us to move confidently towards our first serious prototype.
Okay, so we needed then to find a way to allow the motorbike to sit on something to create the energy. We've then found an unused treadmill which has shafts inside, like these ones. So we dismantled the treadmill and took the shafts out and placed it above the ground so they could spin efficiently and convert this rotation into energy to be able to spin the shaft on the grinder itself. So then we put it on the cardboard prototype and allowed them to spin like this. When the back of the motorbike wheel turns, these will also spin, which will then turn the pulley, and then that way we'll be able to grind different materials. We then needed to be able to transfer the energy efficiently, so we decided to design a pulley on Fusion 360. Our initial few designs had the grooves too close together, so that caused them to melt and not be able to efficiently transfer. So then we filleted the edges and created a V-shaped groove as seen in this one, which allowed the belt to sit properly inside of it and allowed the energy to be transferred efficiently. So for the final version, we decided to make it out of metal. So even if there's high friction, it won't melt and won't change in size. Then after a couple of tests, we realized that the belt was expanding a lot. So we decided to make an idle pulley so that we could create a tension when the belt gets too loose. You can move this idle pulley left or right, depending if it's too loose. And that way you can always have the same tension on the belt, which allows the energy to be transferred at the maximum capacity.
Bernard, one of the technicians we consulted, built a very simple working prototype. It used a single roller, a direct pulley connection, minimal components. His design showed that we are overcomplicating things. Sometimes simpler is stronger. Bernard's vision is more reliable, easier to fix, and more practical. This inspired the direction of our final design.
So after our initial prototype with the wood, we realized that it wasn't strong enough to carry the weight of the shredder and the weight of the motorbike. So we switched to this prototype where we have the one roller, just like the one that Bernard suggested. But we made some modifications. So we added the idle pulley which we had on the wooden prototype, and then we added a few more adjustments which we'll talk about later in the video. Some of the changes we've made to Bernard's prototype include the idle pulley, which we've included in order to keep tension over time as the belt stretches out. This adjustable roller section where we can take it off for transport. These sliders where we can adjust the height of the table for transport, so we can make it shorter when it's going on the motorbike via transport and then longer when it stands still on the floor while grinding. We've also adjusted the size of the table, making it bigger in order to fit a bag or a bucket to collect the grains.
During testing, we realized the motorbike was not staying aligned with the roller. It drifted sideways and vibrated excessively. To solve this, we designed a hooking mechanism that attaches to the bike's suspension, and this locks the bike in position so the wheel stays perfectly centered on the roller. This is a crucial step for a safe operation.
Yeah. So then, this is the full final product of our grinder motorbike powered system. So over here we have the stand for which the grinder will sit on top, and then we have adjustments for the height. So should we need to put it up or put it down to attach it onto the back of the motorbike, or depending on where it's kept, we can adjust that. And then to transfer the energy from the back tire of the motorbike, we have a shaft over here from a broken treadmill, and we've made a pulley which is connected to a belt, which is connected to the pulley of the grinder itself, and also an idle pulley which works as a tensioner to make sure that when the belt gets even loose, we can move it to the left to make sure that the tightness is always there to allow maximum energy transfer. And then this is the grinder. So through the back over here is where you put in the grains, and then these shred it, and it comes out through the bottom. So we've created a hole at the bottom to allow the people using this machine to put a basket or something to catch their newly milled grains. Thank you for watching.